Yeah, hello, my name is Emiliano and I'm going to talk about the limits. The limit is not a concept of a derivation or an equation that uses one point to another. And the limit is usually expressed like lim, L-I-M. It's used about a point. It's used about a point to another point or to point to an infinite point. It can be different type of limits like sequentially limit that comes from an x point to a j point, and then it's like a small space in the j, and it continues of the same point to another point. And then we have a constant limit that, like I say, is like of 1 point x to the infinite.
Hello, my name is Mitzi, Viveros, Cabildo. I'm gonna explain limits in infinity and have some examples to understand better the topic. Say in the case, let's say when you have an exponential bigger than the denominator, you need to know that it grows very bigger and the denominator is grow very little. When you try to divide some bigger number in a little number, your result obviously gonna be a bigger number, and for this the result is infinity. In the case 2, you need to look that has the same exponential numbers, and for the result use the number that is in front, and it's important to look the same. In the case 3, I like this because when you only imagine that you have a donut and you need to divide in 1,000 people. You can divide in this part, and for this your donut gonna convert in 0, and it's the same when you try to divide something in something bigger, your results be 0. In the case 4, you need to do more things. The first is rational side and multiply this with this, this with this, this with this, and this with this. They remove, and the result be this. And if you look, it's the same that in the case 1, and for this your results be infinity. In the case 5, I like this because it's something simple. When you multiply something bigger for something bigger and add other number, obviously.
Hi, my name is Alan. First of all, we need to know what is a function before we should know what is a derivative. Well, a function between two sets that we are going to call a and b is an association that we are going to call f, that each element of a is assigned in an element of b. We can see these representations in a lot of examples of proportionality. For example, if I'm walking to my friend's house and it takes me 30 minutes to arrive there, we can say that we can use a function to describe how much space I have traveled at every moment, or is the same as speed. If I go at the same time and at the same speed, I could say that the function will look completely rectilinear. But if I travel the same distance but a little bit faster, we can say that the function will look a little more close to the axis x or time, because I'm traveling the same distance but in less time. But the derivative helps us to know, for example, if I'm changing my speed in the same distance, my function will not be constant, and the derivative will be help us to know the speed at a certain point of my function, which is not constant clearly. But I forgot to say that a derivative at the same time help us to know in a certain moment the exactly speed, but only if my data is not proportionality or if my velocity is changing between the time.
Hi, my name is Kayro Adrián Aguilar Sánchez, and I'm going to explain how can we solve a derivative. Well, to solve a derivative, we have in this moment this formula that is a function. Well, we have to substitute this part less the original function, and all of this divided between h. So, well, for this example, we are going to work with this function, and to start, we have to substitute this in the original formula. It would be now we need to solve this thing. Solving this one, it will be like this. So if we have this function, we have to add the original one in this part, but we have to change the signs of all the function. Why? Because here we have a negative sign and it is multiplying the function, so we have to change them. So we would have and we add it to this part, so we have, and then as we can see, we have some parts that are similar but they have different signs, so it's easier because we can eliminate them. So we have this one and this one. This is positive and negative, so they gone. And then we have this one and this one. It is positive and it is negative, so there you go. And the last one is this one and this one. This is negative and this is positive, so there you go. And we just have three members that we will write like this. And the last step of this formula is to divide all these between h. If we divide it, we are just going to reduce one h in all the members, so we will get, and then we just disappear this one, and our answer is this is the answer. Well, I know another way that we can solve a derivative, and it is using this formula. I can say that, well, to explain it, is that we have to multiply this number that is with the x, with the x, and we have to multiply it with the actual exponent that is 2. For in this example, for example, 3 for 2 it's 6, and the formula says that the actual exponent we have to less it 1, so 2 less 1 is 1, so is this one. Well, I don't put the 1 because it isn't necessary to put it, and then we continue. We put the same sign, we keep the sign, and then we multiply 4 for the exponent that is, in this case, is 1, so 4 for 1, 4, and we less 1 to the exponent, so 1 less 1 is 0, so the x disappears, and this one it doesn't have an x, neither an exponent, so it just disappeared, and this is the answer of our derivative.
Here I am waiting, I'll have to leave soon. Why am I holding on? We knew this day would come, we knew it all along. How did it come so fast? This is our